There you go. All right. Well, pretty much every single problem is on the test. But I'm going to do a problem that's very similar to some of these. And then we can go to lunch early. Okay, number one, we've seen that on the quiz. Okay, number two. So I'm going to do a problem like problem 2a, but I'll change it a little. How about r squared equal cosine 2 theta? In fact, this is a graph that you're supposed to know, right? What is this graph? It's a lemniscate. Come on, if this is r squared and that's 2 theta, it doesn't matter if it's sine or cosine. This is a lemniscate. Okay, but I'm not asking you to graph it. That's too easy for you guys, right? I want you to change it to a rectangular equation. Okay, so let's say a problem of this caliber is on the test. What are you going to do? A, stare at it. B, skip to the next problem. Or C, use the formulas. It's C, use the formulas. Okay, well, how can I use the formulas, Mr. Park? I don't even see an r cosine theta or an r sine theta. What do? I don't see. Well, you gotta find r cosine theta and r sine theta. Yeah, but Mr. Park, this is cosine 2 theta, so yeah, maybe you gotta use identities then. Uh-oh. Now, cosine 2 theta has 3 identities. Pick one. Okay, my favorite is cosine squared minus sine squared. Okay, now remember, you want r cosine theta because r cosine theta is x and r sine theta is y. So what can I do to both sides of this equation so that I can get these things? Multiply both sides by r or r squared. Why am I waiting for an answer? I'm the dumb one. Multiply both sides by r squared. So you get r squared cosine squared theta minus r squared sine squared theta. And then look, isn't this the same thing as r squared squared, right? R to the 4th. So we have a formula for r squared, right? X squared plus y squared squared is equal to, and then what is this? If r cosine theta is x, then what is this? That's x squared, and what is this? That's y squared, and there you go, that's your rectangular equation. So this is what the rectangular equation of a lemniscate looks like. Nobody knows how to graph this, that's why you gotta know the base graph. So, see, the graph, if you're given a graph, you change it to a rectangular equation, it only works if you know how to graph this. This is not something you know how to graph, that's why you gotta remember that this is a lemniscate, it's a base graph. Because otherwise, this is crazy to graph. Okay. And then I told you, guaranteed, one of the problems on the test is find the distance between 2 points, right? I told you that yesterday. Well, the problem is there, I'm not going to do that one. Okay, number 5. Okay, you know what? I want you guys to try number 5. Okay, so here. I'll outline the problem for you to set it up for you. So r equals 2 plus 4 cosine theta. What is this graph? You guys need to know your base graphs. I'm pretty much going to test you on all of them now. If this number is smaller than that number, inner loop. Okay, so what we do is we plot the quadrantal angles. Okay, plug in 0. What do you got? 1, 2, 3, 4, 5, 6. Pi over 2. Plug it in. What do you get? You get 2 pi. You get negative 2, so you got to go 2 units in the opposite direction, and then 3 pi over 2 is 2. You got to go 2 units in the direction of 3 pi over 2. So the graph looks like this. Here's pi over 2. Here's pi. Here's 3 pi over 2. And then it goes back to 2 pi. Now, next year in the reason why I'm giving you this problem, because next year in calculus, you are going to compute the area of the inner loop part. But in order to compute the area, you have to know when it starts and when it finishes. And that's what the question is. Between what values of theta does the inner loop get formed? So here, look, 0, pi over 2, pi, so it starts somewhere between pi over 2 and pi then, right? But you got to tell me exactly. Where does the thing start and when does it finish? Any ideas? Okay, I'll give you a hint. When you start the inner loop and when you finish the inner loop, how far from the origin are you? 0, because you're right on the origin, right? So what do you think I'm going to do with that? So in other words, I want to know, when are you 0 units from the origin? In other words, when is r 0? Because r tells you how far you are from the origin, right? So I want to know when you are 0 units from the origin. So all you have to do is plug in 0 for r and solve it. That's what you do. Now, can you solve this? Yes. 4 cosine theta equal -2. Cosine theta is equal to -half. See how I make it come out to numbers you're supposed to know? So when is cosine theta equal to -half? 2 pi over 3 and 4 pi over 3. Okay, so at 2 pi over 3, that's when it starts, right? Because then it goes to pi. And then it finishes at 4 pi over 3. So the answer is the inner loop is formed between 2 pi over 3 and 4 pi over 3. And like, again, the reason I give you these problems, because next year, to compute the area of that region, you have to do an integral. You guys don't know what that is, but you're going to do an integral. And then you got to know when it starts and when it ends. That's kind of... Okay, so yes, there's a problem just like this on the test. Hopefully you can get it. Okay, here's another one. I'm going to do a problem like number 6. But number 6 is easy because r never becomes negative. Students, for some reason, they get confused when r becomes negative. So I'm going to do a problem very similar to number 6. R equal... I did the whole problem for you, number 5. I didn't want to do that. Well, too late. It's on film. R equal 1 minus, what if I put a 2 here? Cosine theta over 2. Now, I'm going to give you specific, there's only going to be one problem on the test where you have to plot points. This is it right here. And I'm going to tell you exactly. So I'm going to tell you, graph it from 0 to 4 pi. That means you got to go 2 times around. And then I'm going to tell you theta step is equal to pi over 2. That means plot a point every 90 degrees. Okay? Okay, so we're going to plot a point every 90 degrees. So watch what I'm going to do. 1, 2, 3. I'm not going to, you don't have to draw the concentric circles because you're only plotting a point every 90 degrees. So you're not going to plot a point in between, right? Mr. Park, how come you're making 3? How do I know that r will never be bigger than 3? What's the biggest cosine ever gets? 1. What's the smallest it ever gets? -1. So if this cosine is -1, then you get 1 plus 2, 3. That's the biggest it'll ever get. You won't go past that. Okay, so hopefully you guys are good at plugging in numbers by now. Okay, let's start with 0. Plug in 0 for theta. 0 over 2 is 0. Cosine of 0 is 1. 1 minus 2 is -1. See, that's what students, they get confused when r is negative. But you got to just remember, you go on the opposite side. So here's 0. You got to go 1 unit in the opposite direction. Okay, plug in pi over 2. Pi over 2 over 2 is pi over 4. Cosine of pi over 4? Root 2 over 2, which is about Okay, I told you guys for graphing purposes, radical 2 is approximately 1.4, radical 3 is approximately 1.7. You need to know this, otherwise you don't know where to put the dot. Okay, so cosine of pi over 4 is root 2 over 2, which is about what? 0.7 times 2. 1.4. 1 minus 1.4. Negative 0.4. So at pi over 2, you're going to go to negative 0.4 right there. So the graph, so I would highly suggest you connect the dots as you go, okay? So as you go from 0 to pi over 2, it goes from negative 1 to negative 0.4. Okay? Now we're at pi. Now that one, when you do your homework tonight, number 6, that one is easy because r never is negative. So you don't even have to worry. It's going to be easy. Or maybe I'll go easy on you. Maybe I'll give you one where you don't have to go negative. Okay, plug in pi. This is easy. Okay, plug in pi. Pi over 2, cosine it. 0. 1 minus 0. Okay, so at pi, you get 1. So what do I do? Well, we're at negative 0.4 now. In order to go from negative 0.4 to 1, you have to hit 0 in between. Remember the intermediate value theorem? So negative 0.4, then you got to go to 0, then you go to 1. Again, I'm going to show you this. Look, if you're at negative 0.4 and you got to get to 1, don't you have to hit like, well, this is rectangular coordinates. Don't you have to hit 0 somewhere in between there? See, so negative 0.4, oh here, negative 0.4, then you got to hit 0, then you go to 1. So your graph needs to go through the origin. See, this is what confuses students. What happens when r is negative? Okay, anyway, now we're at 3 pi over 2. What is 3 pi over 2 over 2? 3 pi over 4. What is cosine? Negative root 2 over 2. So what is that? Negative 0.7 times 2. Well, how about times negative 2 then? 1.4 plus 1. 2.4. So it's going to go from 1 to 2.4. So that's easy. See, when it's positive, it's easy. Okay, now we're at 2 pi. 2 pi over 2. Really? Is pi, cosine pi? Negative 1, so 1 plus 2 is 3. See? 3. So it's going to go from 1.4 to 3 gradually. Do not make a straight line. Okay, we continue on. 5 pi over 2. What is 5 pi over 2 over 2? 5 pi over 4. Cosine it. Negative root 2 over 2. The 2's cancel out, so you get 1 plus root 2. So 1 plus 1.4. 2.4. So right there. So it goes from 3 to 2.4. Okay, now we're at 3 pi. Easy. 3 pi over 2 cosine. 0. 1 minus 0 is 1. So it's going to go from 1.4 to 1. Something like that. Okay, now here's the tricky part. Now we're going to plug in 3 pi over 2. 3 pi over 2 over 2. Wait, we're not at 3 pi over 2, we're at 7 pi over 2. 7 pi over 2 over 2. 7 pi over 4. What is the cosine of 7 pi over 4? Positive root 2 over 2. The 2's cancel out, so you get 1 minus root 2. 1 minus 1.4 is negative 0.4. So negative 0.4 is on the opposite side. So we have to get from 1 to positive 0.4. So again, you have to go through the origin. To get from negative 1 to positive 0.4, you got to go through 0. So you're going to go from here, then you got to go through the origin again, then you got to hit that point. And then finally, 4 pi. What happens when you plug in 4 pi? 4 pi over 2 is 2 pi. Cosine of 2 pi is 1. So 1 minus 2 is negative 1. So you got to go from What was this? Negative 0.4 to negative 1. So it's like that. That's what the graph looks like. Crazy, huh? So look, it's like a limousin, but it has a double inner loop. A double inner loop. That's really neat. That's why I put that on the test. So if I go easy on you, then I would probably do this, because then you'll never get a negative, and then it's pretty easy to graph if there's no negative. But if I want you to challenge yourself, then I'll do that. Which one do you prefer? You're still not going to speak up, yeah? All right. All right. Okay, I'm doing all the problems that, okay, number 7. Right now I have 3 problems just like that on the test. I might take one of them off, maybe, I don't know. Okay, but they're all going to be base graphs, so you got to figure out where they intersect. We haven't done that in a while, right? So why don't we pick one of them? Well, let's do one of them. Which one looks interesting? Number A, what do you got in A? You got a rose curve and a circle. Then you got an inner loop and a line. That might be interesting. Or do you want a rose curve and another circle? Pick one. Okay, I'll do A. Why should I expect a response? 7A. R equal cosine 2 theta. I hope you guys know, right? Rose curve, how many petals? There's going to be 4 petals, right? If that number is even, you have twice as many petals. And then R equal negative sine theta. That's a circle. Okay, so the first thing you should do is find where these graphs intersect. So solve the equation simultaneously. So equating the r's, you get cosine 2 theta equals negative sine theta. So you have to be able to solve this equation. Any ideas? Cosine 2 theta here. You got to use identities. Now cosine 2 theta has 3 identities. Which one do I use? The one with the sign, because that's sine over there. 1 minus 2 sine squared. So what happens if I don't know my identities, Mr. Park? Well, you're in a heap of trouble. That's what's going to happen. It's a quadratic equation, so make one side 0. And just remember, if you cannot solve it by hand, I'm not going to put it on the test. So if it's coming out ugly and it's not working out, you did something wrong, right? So 2 sine theta, 1 and 1 minus plus. So therefore, sine theta is either equal to negative half or 1. These are all numbers that you're supposed to know. So sine of what angle is negative half? Wait, I want to get this on the camera. 7 pi over 6, 11 pi over 6. Sine of what angle is 1? Pi over 2. Now you got to give coordinates now. So these are just the theta coordinates. Maybe I should just give you 2, yeah? Because 3 chews up a lot of time. Okay, well, I'll think about that. Okay, so once you get the theta coordinate, how do I get the r coordinate? You plug it back into one of these. Which one looks easier? I think this one, yeah? So if you plug in 7 pi over 6 there, you get negative half. So wouldn't that be half? Okay, and then that's half as well. And then sine of pi over 2 is 1, so that's negative 1. So these are your algebraic points of intersection. Okay, do you guys even remember what a graphical point of intersection is? It's a point on the graph that doesn't show up here. In other words, you only know it's a point of intersection because you drew the graph. That's why they call it a graphical point of intersection. Okay, so I'm thinking this problem is worth 12 points right here because you got a lot, or at the very minimum, 10 points. Okay, so let's draw this graph. So all I need is 1, yeah? All you need is 1. So this is a rose curve. The length of each petal is 1. Now the key is you got to find the tip of the first petal for cosine. Did you guys figure out a pattern yet? Hey, Mr. Park, when it's cosine, the first petal is always at 0. That's right. How come? Because you're going to set this equal to 0 when it's cosine. So the tip of the first petal is at 0. Okay, I want to make this at least semi-accurate. Is that about the same? Okay, good enough. And then they're all going to be equally spaced apart. So here you go, the first petal. And remember, do not overlap the petals. They don't overlap. There you go, that's the graph. Good enough, it's kind of not great, but it's okay. What's this graph?
Circle.
It's a circle. And did you guys figure out the pattern yet? Look, when you have a circle of this form, it's either going to be here, here, there, or there. Yes, you didn't notice the pattern. The cosine one is either here or here. The sine one is either there or there. Anyway, what did I tell you to do when you graph the circle? Plot, what are the 2 points you plot? 0 and pi over 2. Okay, you plug in 0, you get 0. You plug in pi over 2, you get -1. So the circle's over here. There's the circle right there. Now let's check all the points of intersection. 7 pi over 6, 1/2. So if you measure off an angle of 7 pi over 6 and you go half a unit from the origin, that's that point. What about this point? 11 pi over 6, so that's that point. And then what about this point? Pi over 2, -1, that's this point. So these are the 3 points that we got from solving the equations. Are there any other points of intersection that you see? Yeah, right there, the pole. But it didn't show up here. How come it doesn't show up here? Because it doesn't get there at the same time. Yeah? So then you need to say the pole is a graphical point of intersection. Because the only way you can tell is by drawing the graph. That's what a graphical point of intersection is. Okay, you convinced me, even though you didn't say anything. I'll only give you 2 of those instead of 3. I gotta figure out which one to take out now. Okay, the last problem I want to show you before we go to lunch is, where is it? Okay, so starting from number 8, this is all last night's homework, yeah? Now I'm gonna tell you, you are gonna get a problem just like this one right here. Obviously, I wrote this problem in 1994. What is this year? 2021. I guarantee you, you're gonna get a problem. It's gonna have something to the 2021 power. Be ready for it. So if you can do 1994, you should be able to do 2021, right? Okay, number 9 is the complex roots theorem. Okay, number 10. So this is how you have to extend your thinking. But I'm not expecting you to extend it on the test. You extend the thinking here, I'll give you like a very similar problem. So this problem is on the test, okay? Pretty much every single problem up there is on the test. Okay, number 10. Z is equal to 1 over root 2 plus 1 over root 2i. Compute, okay, forget the find the imaginary part, just compute this number, okay? What is z plus z squared plus z cubed plus z to the 4th all the way up until, what does it go up until? 2002. Obviously, that's when I wrote this problem. If I give you this problem, you might see 2001 there. I mean 2021. Okay, so how do you raise complex numbers to powers? What did we learn yesterday? De Moivre's theorem. Which means you have to change this into R-KISS theta form. In fact, when you hit number 8, 9, and 10, you've got to change everything to R-KISS theta form because that's the only way you can apply the theorems. They have to be in polar form. So what's the fastest way? Oh, we got to know. See, everybody had a chance to get it. See, because if I just walked straight from the door to her, then those people over there didn't have a chance. You gotta give them a chance. Okay, so what do? What's the fastest way to change from standard form? Well, you gotta go right away.
I forgot to do my randomness.
Well, how come they waited till now? I don't know. Okay, you gotta go. Watch the video then. This problem's on the test. Okay, quick. We want to go to lunch early. How do you change it from standard to polar? What's the fastest way? Draw the picture. Real. You guys don't even label your axis on it. If I go 1 over root 2 to the right, so basically plot the point 1 over root 2, 1 over root 2, and 1 over root 2 up. How far from the origin am I? What is R? This is R. 1. It's 1. You guys know why? Because this is a 45, 45, 90 triangle. If you know the side, you multiply it by radical 2 to get the hypotenuse. It's 1. And then what's that angle right there? You can just clearly see what it is. Pi over 4, 45 degrees. Okay, now once you get that, okay, that's what Z is. Z is 1 kiss pi over 4. So if you didn't do last night's homework, of course, you don't even know what you're doing. That's why you got to do the homework when it's assigned. Now, how do I square this? So here's Z. How do you square it? You use de Moivre's theorem. How do you raise a, here, I'll do it on the side here. How do you raise a complex number to a power? That's de Moivre's theorem. What do I do with the 1? You square it. What is 1 squared? And then what do I do with the angle? You multiply it by 2. What is pi over 2 times 2? Pi over 2. Okay, now we got to cube it. Okay, how do you cube a complex number? You raise 1 to the 3rd power. 1. Okay, that took a while. And then you multiply the angle times the power. See, de Moivre's theorem is really easy to use, but it's so powerful. Okay, what is Z to the 4th? How do I raise it to the 4th power now? What is 1 to the 4th? And then this times that. And then you keep on going till you get there. Now, the key is you got to figure out a pattern, because we're not going to write 2002 terms out. So what did I do yesterday? You draw the graph. Okay, here is a circle of radius 1. How do you graph this complex number here? You make a vector that's 1 unit long, making an angle of pi over 4. So it looks like that. Okay, how do you draw this one? 1 unit long, making an angle of pi over 2. That one. That one. And then if I just continue this, okay, that's the first 8. Now you guys in physics, tell the people who don't have physics now, what happens when I add these 8 vectors up?
0.
You get 0. They cancel out. Who takes physics here? Didn't you guys learn that if a vector has the same length but it points in the opposite direction and another one in the opposite direction, they cancel each other out? So this one cancels this one cancels down, down, and down, down, down. You get 0. Also, what did we just discover in this problem? Every 8 consecutive ones cancel out to 0. How does that help me solve this problem? Because I got to add up 2,000 of 2 of these. If I know, come on people, this is an easy pattern. If every 8 consecutive ones cancel out to 0, and there's 2,002 of them, how many are going to be left? Okay, does 8 go into 2,000? Okay, let's try. 2,000 divided by 8. Does it go even? Do I have to actually do this? Yes, 8 goes into 2,000. Okay, how many? Okay, let's do it. 250 times. So, in other words, if every 8 cancels out to 0, there's going to be 250 groups of 8 that cancel out to 0, which means there's going to be 2 left over, right? Which 2 are left over? The first 2 or the last 2? It doesn't matter, right? It doesn't matter. So let's just go with the first 2, because every 8 consecutive ones, because this is 2,000 right here, these are all going to cancel out to 0. So the only 2 left are either the first 2 or the last 2, but they're the same thing, if you think about it, okay? So what were the first 2? Z, this one here, and Z squared. These are the 2 that are left over. Okay, so the answer is 1 kiss pi over 4 plus 1 kiss pi over 2. These are the two that are left over. Everything else canceled out. Now you gotta change it back into a plus bi form. Let's do this so we can go to lunch. Okay, how do you change it? Are you guys good at changing it back yet? What is the cosine of pi over 4? Root 2 over 2 times 1, so that's just root 2 over 2. What is the sine of pi over 4? Root 2 over 2 times the 1 here, so that's root 2 over 2, and you always put the I on the second one, right? Okay, what is the cosine of pi over 2? 0 times 1 is 0. What is the sine of pi over 2? 1. What is 1 times 1? 1, 1i. Okay, so when you work with complex numbers, you put okay, here are the real parts. So you get root 2 over 2 plus 0, I'm not going to write the plus 0, plus these two are imaginary things, so if I add that up, you get root 2 over 2 plus 1i. So this would be your answer. However, on that it says find the imaginary part. So your answer is just this. See, this is called the real part. This is called the imaginary part. On the test, I'm just going to tell you find it. Okay, so this would be your answer for the test. Okay. Okay, so the only thing so all I can tell you is you have to figure out the pattern. Like in this particular problem, every 8 canceled out to 0. Is it always going to be 8? No. Sometimes it's every 6. Sometimes it's every 12. Sometimes it's every 3. Sometimes it's every 16. You don't know until you actually start writing this out. So this problem really isn't that difficult, but you have to have the basics down in order to do it. This is the last problem on the test. It's always the last problem on the test, just like that one right there. Okay, so all I can tell you, make sure you can do all of these, because some of you kind of need a big number because this ends the quarter, right? We need a big number. So do these problems. Okay, we are done. Let's go to lunch. No, yeah, so like if you have 2 plus 3i, the imaginary part is 3.
Oh, okay.
Yeah.
Oh, and
Yeah, but if you wrote 3i, I'd probably give you credit.
okay, and then when you write it, radical,
Say that again?
radical, you put the argument.
If you want to. Some people write it in the front, so like you can tell it's not in the parentheses. It doesn't matter, as long as it's clear, so you can write radical 3, and then just make sure the I is outside the radical side. Okay, see you, do I see you tomorrow? Yes, I do.